Hello and welcome back to the History and Philosophy of Science in 6 Easy Steps. This is your Week 4 intro video, but we want to start, of course, with our Week 3 recap. So, in Week 3 we were focused on Karl Popper, another prominent philosopher of science, and secondly, comparing him to Thomas Kuhn and what we learned about Thomas Kuhn's views. This was another challenging week. I think, honestly, Weeks 2 and 3 are probably by far the most challenging of the whole course, because that's where we're really delving into these difficult readings in Thomas Kuhn and Karl Popper. And if you had trouble with those readings, you are not alone. Those are tough readings. They're definitely above high school level, by the way. So you should congratulate yourselves on grasping what those readings are saying, even if you just got it at the basic level. So, looking at Popper, a few key things we want to point out, and I'm going to mix in some feedback on your work as well with this kind of recap. But of course, his focus is on conjectures and refutations. So what he's doing is he's trying to define science. He's trying to demarcate science between science and non-science, or science and what he calls pseudoscience. And so what he comes up with is this definition of science that says that science is all about making conjectures and then trying to refute them or falsify them. Later in the essay, he likens this process to trial and error, or to just having a critical mindset, looking at everything with a critical eye. So that's what science is all about, according to Karl Popper. And so to apply this specifically, what he'll do is looking at, say, something that's claiming to be a science. So let's say astrology. He's going to ask some questions. Does it make specific conjectures and then try to refute itself? Or does it make statements or predictions that are specific enough to be falsified? And then secondly, what happens when they are falsified? How do the practitioners of this field respond? Do they reinterpret things in light of their theory so that it comes out smelling like a rose? Or do they say, hey, whoa, we were wrong, let's move on? So that's what we're looking at here. I think of an argument here that some young earth creationists have, for example, and this is one of the options I put up there for pseudoscience. The young earth creationists is an interesting case, because those people say that the scientists, and some of them are scientists, they have science degrees and backgrounds, they say that the earth is, say, 5,000 to 10,000 years old. And when you say that, there are specific predictions that could be made based on that. So that means when we do radiometric dating, we shouldn't find any rocks younger than that. So in that sense, the theory itself, there's nothing unscientific about it. It can make very specific predictions. But then we have to apply this other concept of Popper, which is, okay, so now what do we do? So when we look at the rocks and it says it's 500 million years old, what do we do then? Do we try to explain it away, like say it was contaminated samples, or make up something like, the half-life is not constant, or some sort of kind of ad hoc or after-the-fact sort of explanation? So that's what we're looking at, and that's how we can identify whether something's scientific or not, according to Karl Popper. Now, I wanted to bring up the example of psychology because, of course, Karl Popper uses the example of psychology a lot. But remember, when he wrote this, it was in the 1950s. And when he first started dealing with these issues, according to Popper himself, it was like 1919. And the psychology of the day was dominated by Freudian psychology and also the teachings of a psychologist named Adler. And their theories did not fit Popper's criteria of what makes something scientific. So that's pretty clear. But then, so some of you took this on in your essay and said that modern psychology, and questioned whether modern psychology was scientific, which is really an interesting question, right? It's an interesting topic. It's very important. But I felt like in a couple of your essays you might have gotten a little bit confused by the fact that Popper's sort of attack on psychology was based on an old version and outdated theories of psychology which are not in use today. I would argue that much of psychology today for example, the positive psychology that's become very popular, is based on research. It's got theories that are rooted in neurological science and that can be tested with experiments and falsified. Now, what do you do when they're falsified? You have to ask that question. What does a particular scientist do, or what does that field do when their theories are seem to be falsified or appear to be falsified? But anyway, I think that I just wanted to clear that up a little bit. When we're talking about modern psychology, something very different than what Karl Popper was talking about. Okay, so some specific feedback on some of your papers. Looked like there was considerable confusion about induction, and I had considered putting another reading in this week from David Hume when he originally brought up the problem of induction, and maybe that would have helped. I was worried it would be a little bit too much work for you, but and by the way, let me know if you think how much work there is here, or if you think it's too much, and so on. But there was some confusion on induction. So induction is the idea that we expect things to continue as they are. So you can look at it in terms of time. So like I drop a rock today and it falls to the ground, so I expect that it's going to do so in the future. That's reasoning by induction, or it's pretty much the same as making an inference based on what we see right now. But we can also reason inductively in space. So I can say if I drop a rock in Thailand, it will fall to the ground. And then we can even broaden it even more and say, not only if I drop a rock, but if I drop a feather, it will fall to the ground. So you see, that's induction. And what David Hume had said was, there's no reasonable argument for that. Why should a feather fall to the ground if just because a rock falls to the ground? Okay, so there's no logical argument for that. Now, of course, we could say, well, because of gravity, that's why they're all going to, but that kind of confuses the issue, because gravity presumably was developed from those data, right? So, and in the case of gravity, we're not actually making that inference about the feather falling based on the rock falling. We're making it based on our theory. So in this case, let's say I say, okay, well, sorry, let me go back. There's two ways to do it. I say the rock falls, and every time I've dropped a rock, it's fallen. Therefore, other rocks will fall. Other rocks will fall in the future and in other places, and feathers will fall. Okay, that in and of itself does not constitute a logical argument. Okay, it might make intuitive sense, but that's the point, right? Is that induction is just intuitive. It's not logical. But then if I take the other approach and say, okay, so I've got this theory of gravity, which is basically that all these things are going to fall. Now when I drop the feather, what am I doing? I'm trying to refute it. I'm testing it. I am attempting to falsify the theory. So now I'm doing what Popper was talking about. Okay, so that's induction versus what we could even call deduction, or more of a deductive reasoning process, what Popper calls falsification. Okay, I hope that clears it up a little bit. Maybe I just confused you even more. Another example of induction, really quick. All the swans I've seen are white, therefore all swans are white, right? That's a form of inductive reasoning, and it's not really a valid argument, right? In fact, there are some black swans out there in the world. Or I've never seen a gnome running around in my garden, so therefore gnomes don't exist, right? Another form of inductive reasoning. So there's some problems with that, and Popper was dealing with that in the later part of his essay. In fact, what Popper says is that not only is this not valid reasoning, but we don't actually do it. Now this is where I think it gets a little bit controversial, because David Hume said that we do it, but it's more of an intuitive thing. It's like a habit of our minds that we expect things to be like this. And Popper says he doesn't really think science proceeds like this at all, that we actually proceed through conjectures and refutations, although he does allow that our brains have expectations of regularity. Okay, but then I guess what he would say is that, so we have this expectation of regularity, but we're continually checking it. and falsifying it. Okay, and that's where I think he does get a little bit controversial, and I'd like to hear your thoughts on what you think about his views on that. Now, does Thomas Kuhn support induction? This is another area of confusion. I think some of you seem to equate Kuhn with induction and then Popper with falsification. But I'm not sure that Kuhn really does that. I'm not sure he really speaks to the issue of induction, and you can correct me if you think I'm wrong, that he talks about, kind of reasoning from the specific to the general, which is the heart of the inductive process. So I'm not sure he does address that, and I don't think we can equate him with that. In fact, I think we can equate his anomalies and his the role of anomalies as being pretty much the same as the falsification process. But where he would disagree is that the falsification process is not rational, that it's more of a subjective or intuitive kind of thing. He doesn't get into a lot of detail, Kuhn, on that, but he does seem to kind of paint this more irrational picture that happens during that transition, during the paradigm shift. It's a little bit fuzzy what exactly he's saying. I liked some of the examples that you all brought up of pseudosciences. One of you talked about astrology and how it doesn't make specific predictions. As I mentioned, two, we're struggling with the whole concept of psychology and modern psychology, and one brought up Dianetics, which is a part of Scientology, which is really kind of a religion that Tom Cruise and I think who else? John Travolta, maybe, a couple of famous actors that are all tied up in that. So interesting reading there. The infographics, some great designs on that. I really enjoyed looking at that. I got to do more alternative assignments like this. In fact, you're going to have an infographic option on one of this week's assignments as well, which we'll get to. Some of the key differences between Thomas Kuhn and Karl Popper that you brought out, right? Things like rationality. This was one of the keys, right? I think probably that's where they would have disagreed the most, and where they did disagree the most historically, is on this concept of, is science a rational process? Does it proceed rationally? And I mentioned, if you're interested in this stuff, look up this guy named Michael Polanyi, because he got into this in a lot more depth, and I think decisively answered the question that it's really not all a rational process at all. He got into much more depth than Thomas Kuhn on that. And that calls into question the whole process thing. Progress of science. So, how does science progress? And I think that Kuhn and Popper do have different kind of perspectives on that, don't they, on how it progresses. Paradigms versus falsification as the way to demarcate between science and non-science. Kuhn actually does define science. Basically, he sort of defines it as a field that has this kind of paradigm approach, right? Where everybody agrees on the way to do things, and then they go about using that as problem solving. Whereas Popper's demarcation is very different, right? It's based on this conjecture and falsification process. The key point that somebody brought out that I thought was really cool is that both of them basically conclude that we can never really be sure we're right. We can never really be sure we have the truth. Now, the only place where this would break down is if you think about it, and this is one of my issues with Popper. And Kuhn talked about this as well. Kuhn talked about what degree of falsification does Popper need. So Popper talks about, falsifying a theory. But let's say I drop a rock today and it doesn't fall to the ground. Does that totally falsify the theory of gravity? What if something else was going on? What if there were some strange phenomenon, a giant asteroid just passed overhead and its gravity offset the Earth, or I don't know what would happen. But what if something strange were happening and that could account for that anomaly, right? Because it would be an anomaly. So I think Popper might have had a little bit too much faith in the rationality of the falsification process. One of the things that Polanyi brings out is that what happens is there's a subjective element to when we become convinced of something. How many instances of the anomaly would it take to convince you? Well, that's going to differ from person to person, and I'm not sure that we could say that's objective. It's subjective, which means it's something from within us. It's psychological. It's intuitive, right? How much does it take to convince you? And that's, I think, where Kuhn was struggling with. What causes why do some people make the switch to new paradigm and some people don't? Because it's a personal thing. In fact, that's the title of Michael Polanyi's book. It's called Personal Knowledge. Very interesting stuff here. And in fact, that's one of the things I love about this course. It's really one of the reasons I created it, is because I think it's so fascinating to realize that science is not this kind of sterile, mechanical thing. It can't be, because it's a human endeavor. And we're very much a part of this process as humans and as personalities, right? But key difference between Popper and Kuhn, right? Very different focus. In fact, I'm wondering if some of you struggled a little bit with that, because, in fact, I know you did, because at least one of you mentioned it. Popper was specifically devoting his essay to drawing the line between science and non-science, whereas while Kuhn mentioned that, his focus was on building an overall framework of how science works through history, right, with a specific emphasis on scientific revolutions. All right, but great job with those. Those were very challenging. Just a reminder, some encouragement here. You're going to see a lot of comments on there, a lot of areas where you can improve. Some of you may not be happy with your scores so far, but you know what? Those are not set in stone at all. When you redo and resubmit an assignment, you don't get a grade that's averaged with your old one. You get a new grade. Whatever your final grade you get on that thing is the grade that you get. So go on there, look at the rubrics, look at the comments I made, make specific changes, and get a better score. It's as easy as that. Feel free to ask me, could you clarify what you said here? How can I improve this? Feel free to email me, tweet at me, whatever you'd like. Okay, week 4. And I'm going a little long here, so I'm going to wrap this up quickly. We are halfway there, folks. You have only 3 more weeks of new material. And so far we've looked at the history of science. We've looked at what I would consider 2 of the most important philosophers of science. I could add Michael Polanyi to that. But what we're going to get into this week is we're going to kind of make a switch. And we're going to start looking at science from some different perspectives. So in this first one, we're focusing in on what has been called the scientific revolution. Now this is an interesting term, because now that we've looked at Kuhn's book, he talks about scientific revolutions in the plural, but there's something that is called the scientific revolution, okay? And this is your task. Assignment 12 is really a research project. You're going to define the scientific revolution, pinpoint it in time and place, where did it happen, and you're going to say, finally, what would Kuhn and Popper have to say about this? In other words, how can you apply your understanding of science, what you've got from the reading so far, how can you apply it to this topic of the scientific revolution? What is the nature of that revolution, right? So, Popper's contribution would probably be, for example, when did people start to use Popper's method, for example? You know what I'm getting at. So I want you to bring out all those things. Make sure you cite multiple sources here. I'm not giving you any sources for this other than Kuhn and Popper, so you're going to have to do some research on the web. Assignment 13 is, by the way, assignment 12, you can choose to do an infographic for that. Of course, it's not going to be a comparison infographic, but there's a lot of different kinds of infographics. And again, I really enjoyed looking at your last ones. Assignment 13 is a position paper. We're looking at something that has been called the European miracle. And I'm going to give away part of 12 here because the scientific revolution happened in Europe. The question is, why? Hint, it is not because some sort of race superiority thing, right? So why is it? And there's been a lot of thought on this, a lot of people going back and forth on this, and I've given you 2 primary resources. One is an article from an Indian journal of science about this very question. And this is a really cool article because the author goes into a lot of different potential explanations. So it's a great source for you. The second is a movie and a Wikipedia summary that are based on a book by a man named Jared Diamond. The book is called Guns, Germs, and Steel. And in this book, he lays out his theory, which is a pretty novel theory of why the scientific and revolution happened in Europe. So why did Europe become so much more advanced so much more quickly than the rest of the world, starting with the scientific revolution? So that is addressed in the movie, and again, read the Wikipedia summary. If you want to read the book, it's a fantastic book, but I can't require it for this class. It's just too long. So that's what we're looking at. We're looking at what is a scientific revolution, where and when, and then why there. Okay, what were the factors? So what we're doing now is we're starting to look at connections between science and society. This week, we're looking at the influence of society on science. So effects, things that affect science. Next week, we're going to be looking at the opposite. How has science affected society? Okay? Note on the rubrics. Make sure you read those rubrics carefully before you do the assignment. In fact, use them as a guide. For example, big room for improvement on the paper. This from last week was not the paper, but the infographic was the use of evidence. I didn't mention it in the assignment description, but it was on the rubric. So how do you do that? A good way to do that, and if you want to get those points back, go back into your infographic and put in a few quotes, okay, a few specific paraphrases, couple of examples that Kuhn or Popper used. And you wouldn't have to do this for every one of your points, but just enough to show that you're using specific evidence. Okay, so use the rubrics as a guide for you. Twitter, I think you all are getting the hang of this. Somebody mentioned it was kind of hard to find the questions and so forth, and Twitter does take some getting used to, just like anything new, any kind of technology. But I think it's going to be worth it for you. It is a great way to engage with people from around the world, and I do this on a regular basis. I've had a lot of fun with it. I've learned a lot through that medium. And also, I think one thing that's really cool about Twitter is the 140 character limit. It forces us to really condense our thoughts. Sometimes over condense them, but I try to keep the questions such that I think you can put together a one sentence answer. And again, my hope with this course is that you would gain perspective, a new perspective on science, a perspective that science is, really a perspective on the personality of science. So what is science all about? How does it function? How does it work? And I hope you've already learned a lot about that. And also, though, the power of science, the power of this way of thinking, this way of looking at the world. Okay, so I hope that you're getting a lot out of this. I am enjoying interacting with you through your work and through Twitter, email, whatever, and I'm learning a lot as well. So good luck on this week's assignments. Let me know if you have any questions, and don't forget to keep up with the stream on Google Classroom. Okay, have a great day.